welcome everyone. So today's webinar is Picking the Low-Hanging Fruit. And as always, my name is Michael Pagel, Program Manager, to welcome you to our webinar today. For those not familiar with the term, it refers to conservation measures which are mainly easy to identify. They could be operational changes or low-cost measures, and they could result in very high savings potential, especially if your hospital's energy profile is sort of on the less efficient side or showing more of a high savings potential. You should always consider all of these measures discussed today, even if you think they've already been completed before, because as we find, the low-hanging fruit can grow back very quickly, and past changes are reverted to previous operations kind of very easily if you're not keeping on top of things or monitoring the savings that you're expecting to see from these conservation measures. And we'll just run through our program partners and sponsors here. So we're partnered with CHES, the Canadian Healthcare Engineering Society, and our industry members and program supporters are Belimo, Blackstone Energy, Elliston, Enbridge Gas, ENS, QMC, Sabon Energy, Smith & Anderson, and Thermogenics Boilers. Enerlife provides the technical direction of the program. And you can use the Q&A option for any questions today or, any technical issues that you might have. Just let us know and we can help with that. And the presentation and recording of this webinar will be posted to our website later this week. That's greeninghc.com. And now I'll introduce Ian Jarvis, Executive Director of the Climate Challenge Network, to start off with the land acknowledgement.
Great, thank you, Michael. And let's begin as we always do with Climate Challenge Network events by acknowledging the ancestral and unceded territory of the Inuit, the Métis, the First Nations people that share these lands with us. We're meeting today on a virtual platform, but I'm speaking from the traditional homes in Toronto of the Huron-Wendat, the Haudenosaunee, the Anishinaabe, and the Mississaugas of the Credit River. And as we talk today about the environment and the land and our collective future, it is our hope, our intention that our work will contribute to a common responsibility as stewards of the environment. Let me begin with the agenda. We got a fairly simple agenda. We got 1 hour to work through 5 issues. I'm going to spend a bit of time again setting the stage with this around keywords for all of us today, that there's urgency and commitment around the climate crisis, which presents opportunities and responsibilities. And today is our ongoing work to enable and make it as easy as we reasonably can for hospitals everywhere to take action with respect to energy efficiency and emissions reduction. We're going to spend a little bit of time talking about, once again, using your greening healthcare scorecard, your greening healthcare metrics and profile to identify the best measures. So I'm joined by my colleague Amandeep Dayal, who's the Director of Engineering for Enerlife Consulting. He'll be sharing his experiences with these measures. When we talk about the low-hanging fruit, we pick the top 5. Not everybody's going to agree that these are the right top 5, but and there'll be future events looking at more measures. But we wanted to look at what we think is the biggest, which is HVAC scheduling, particularly in non-clinical type 3 spaces. We talk about boiler plant optimization of the control of heat recovery wheels, lighting retrofits, and pumping systems. These are all the areas where, as Michael said, we've seen opportunities which people aren't necessarily grasping. And today we're going to learn more from you about what gets in the way of doing these kind of things, what kind of help, what kind of support that we and the many industry players and governments and utilities that are on this call today, they're very interested in what they can do to help every hospital move forward. At the end of this session, we'll talk a bit about planning for success and greening healthcare program that's yet to come in 2024. Today, the focus is on 5 issues, summarizing what's to be done, and we're going to be taking a poll at the end of each of these issues. We asked just the hospitals to respond to the poll. It'll come up after, again, each of the 5 sections of the agenda. just the hospitals respond, but government and industry participants on this call will be very interested in the feedback and where we can all help move this agenda forward. So it's going to be polling. We ask you to participate if you're a hospital. If you've got multiple hospitals, which a number of you do, choose one that you think might be the best candidate, but respond to us about the current state and what's getting in the way of action, and that will guide our program for the balance of this year. So let me, with no apology, for those of you who are part of the annual forum last December and the webinars we've had since, the context for this is very clear. It's around urgency, it's around commitment, it's around the 2030 first milestone in terms of emissions reductions for both sides of the border in both Canada and the United States. That's where the first commitments are. The determination that if we need to meet the 2030 targets to make 2040 possible, to make 2050 achievable. 2050, as I think everybody knows, is net zero. The trajectory we're on today, as of 2024, we're going in the wrong direction, and we're going to miss the target by a wide margin. As Dr. Ballum, in her keynote at the forum in December, put it, we're running out of time. We can't expect governments to fix this. They can support it. They can put policy in place. But ultimately, solving the climate problem, solving the climate crisis is individual responsibility, individual action. Every hospital has a disproportionate size role to play. And again, the opportunity to reduce utility costs, to save emissions, to feel good about what we're doing, but also has the responsibility to take this moment. We have next generations that we're responding to. It was a time of urgency, a time of commitment, a time of opportunity, a time of responsibility. And we hope today will help every hospital on this call move forward. We talked about setting direction, that you all have your medical tests that Greening Healthcare has provided for you. About half the hospitals on the call today are not currently members of Greening Healthcare. If you follow up with Michael after this, we will run similar metrics for you. But this chart you've seen before, it's the savings potential of 55 of the hospitals that are currently members of the Greening Healthcare program. The orange is the thermal energy, typically natural gas. The green is electricity. The biggest savings are in thermal energy, and that's where the biggest greenhouse gas emissions are. But every hospital that's part of Greening Healthcare, you have this scorecard. The reporting that you get, the annual report, I'll remind you of that in just a moment, is broken into components. The analytics separate your base year-round electricity use, which points to ventilation, lighting, elevators, medical equipment, things that run year-round, from your cooling electricity, which is your air conditioning plant, and the cooling loads attached to your ventilation systems. So you've got component benchmarks that you can look to see where are the weaknesses, where are the biggest opportunities in each hospital. Same with thermal. We can separate base thermal, which is mostly simultaneous heating and cooling in your air handling systems, but also domestic hot water and boiler plant inefficiencies. We can separate those from your heating thermal. You have these metrics already, and you have direction as to which, opportunities they're pointing to. So use the data, because simply there is no time to search everything down. You have to focus on the areas of biggest opportunity. These are the kind of results that you see. Here are two hospitals. The hospital at the top, you can see the big opportunities highlighted are base thermal, the 42.1 equivalent kilowatt hours per square foot. For our American friends, multiply that by 3.4 and you have comparable numbers. And the cooling electric, both of those are substantially higher than they should be. They're telling you you've got big opportunities around ventilation systems and simultaneous heating and cooling. The lower hospital, different kind of scenario. In this case, it's the base electricity, so it's lighting, it's fan power, and it's heating thermal is the biggest opportunity. So it's bringing in too much outside air, not running the heat recovery systems around the outside air very effectively. Both hospitals, you can see these numbers, there's six-figure savings potential. and most hospitals are. If 100 hospitals, there are 73 hospital representatives on this call today. With well over 200 sites they're responsible for. If 100 of those move forward, on average, we're going to save about $10 million a year and about 25,000 tons of emissions. These are big numbers. These are important. We need to make it happen. Your annual report, reminding you where that is. If you've lost track of it, contact Michael. He'll pull it back up for you. But that chart that we just saw for the two example hospitals, that's in the bottom left-hand corner of the front page. Your actual savings are on the right-hand side. You've got your annual reports for 2024. Those are your clearest direction on where to look for savings, where to look for opportunities. So know where you stand, know your savings potential. It forms the business case for action, and the environmental case for action is self-evident. We see it on the news every day. We see it on fires and smoke days and respiratory diseases and all the things that are becoming way too familiar. We have a chance to make a difference. So taking action, the top 5. Again, we spent a bit of time with hospitals thinking about what are the most actionable, some of the biggest, but the most actionable measures we've taken. We've chosen 5. The process here very simply is I'll introduce each one. Amandeep is going to speak to how do you set about tackling these things from the experience he has, again, with dozens of hospitals he's working with across Canada and the United States. And then we're going to come to a poll. And again, we'd ask every hospital on the call today, take part in the poll. It'll just take a moment, put your information in, and we and the government folks we work with, the utility folks, will use this information to help put in programming and support to enable things to move forward. So that's the plan for the day. We're going to look to get through as much of this as we can in the hour we have available. And this will not be the last session like this. We'll be bringing, subject to your feedback, we'll be bringing similar ideas forward in the future. So let's start with number 1. It's surprising to every regulator, every policy person we talk to, that the biggest part of energy and emissions reductions in hospitals and many other buildings is simply switching things off, turning them down when we don't need them. You'll recognize the Alberta Health Services will recognize these diagrams. First, you figure out the occupancy hours of the zones you're using. Then you look at the zoning of the HVAC system serving those. Then you move into the area of what can we do about this. So the number 1 for your consideration is making sure every non-clinical space in the hospital, that the air handling systems serving those spaces are scheduled as well as they can be. And Amandeep, over to you. You'd put together this framework of how do we plan for these things? How do we implement them? Who do we have to involve? How do we make sure they're working properly? And what should we be thinking about for next year and the year after capital budget? But talk about ventilation scheduling, this one. It's the big one.
Yeah, thanks, Ian. I think generally, as we visit a lot of these hospitals, there's challenges in sometimes implementing these measures, and it's not a technology, it's not these systems are not set up. It's generally around how do we sort of bring that focus around these opportunities back to the operations. So and sometimes there is misconceptions around or less information about we need to involve how many people to get this work done. I think the simple things that I see in a lot of things is that your building operators are the ones who actually run these buildings, and they're the one who knows most about these buildings. So if you put together a task for them to go out and find out the systems first, which you could schedule them where there's no occupancy, and then that basically starts with mapping the information on any drawings. So you have a set of drawings that you can ask your operations team, dedicated person to sort of do that HVAC zoning first information, and then confirm the hours, and then start with the non-clinical spaces as a starting point to either shut down or reduce airflow on those systems when there's no occupancy in the building. There are many spaces and easy spaces in the hospitals that you can start with. like admin spaces, offices, where there's no occupancy after 5:30, but there's still HVAC systems are running. So picking up on those systems, building up on the success of the easy systems, then you can move on to other spaces of type 2 and type 3. But again, it generally there it's never been done, and then there's been perception always about the hospitals are supposed to run 24/7, but that's not the case here. So if you're the easiest thing to do is have a dedicated person on your team. Start this action with planning which spaces you're going to tackle first, which your handling units you're going to tackle first. Engage your utility company for incentives. Work with your building automation controls contractor to implement that reset schedule on them. Monitor the performance of the systems for any complaints, and make sure you also communicate with the departments in that whole process to inform that this is happening. So they 99% of the times the department appreciate what you're doing because they don't understand the impact of the climate that these systems make, and they tend to be part of that program, not a hindrance to any of these opportunities.
And Amandeep, we've seen this being the biggest source of savings. When we see our top savers every year, scheduling is typically the biggest area that they're tackling first. It shows up on the meters. We've seen hospitals saving $100,000 a year simply by tackling the non-clinical areas. Is that right?
Yes, and then the reason for that is not only does it impact the electricity consumption, but it also helps on the gas as well, right? And not only does it do, like when you look at the component analysis, it hit heavy component analysis. Your base electricity, your electric cooling, your base thermal and heating thermal, all those components get impacted, or you get savings in all those components when you make the scheduling change. So it is one of the biggest, I guess the one of the lowest hanging fruit that has the biggest impact on your utility consumption.
Great. So let's move on to the poll. And Michael, if you can pull that up right now. And again, please, every hospital, not non-hospital participants, just the hospitals. If you can fill in the answers to these questions. The first one is about how much of your hospital in the non-clinical areas is currently being scheduled. Is it very little? Is it or is it most of it already? And again, this is all anonymous, no attribution, but real interest in the responses to where that works.
While the poll is going, I just want to make another comment, Dean, is sometimes what we see when we go to the sites is that sometimes the feedback we get is, yes, we have scheduled these systems. Yes, we have looked at that, but in reality, what happens with a lot of these systems if they're scheduled or if they're turned on based on a static pressure reset, for example, some of the hospitals which are old, they don't see materially change in the VFD speeds, because what happens is that even the boxes downstream are being closed, all of that pressure is lost in the leakage of those ductworks as well. So pressure doesn't build up, hence the VFD doesn't back out the systems, even though there seems to be scheduled, but they're still running at the same VFD speeds as well. And in some cases, the systems seems to be scheduled, but they're not showing up on the meter as being scheduled. So it's good to look at the meter profile, your utility data, interval meter data analysis to also confirm you're actually seeing those savings at the meter as well. Let's
move on to number 2. So scheduling systems and equipment, the biggest single thing that you can do, and accessible with manageable effort with your own resources. The key here is with the boiler plant optimization. This, if you were part of our summer workshop last year in 2023, you heard this case story. These are actually the picture from South Lake Hospital, where Thermogenics has been working with the hospital to maximize the efficiency of an aging steam boiler plant within greening healthcare. You can see the checklist on the right-hand side there. It's just a partial of that checklist, but all the ideas, all of the opportunities with respect to improving heating plant efficiency are within that checklist. And you can see how it works. You can say what you've already done, what's a good idea, what's not a good opportunity in the different places. But the idea of taking that checklist and applying it with your boiler service contractor within your own heating plant, this becomes the next major opportunity. At Southlake, they're already recording savings in excess of $100,000 a year by tuning up their boiler plant. We reported on that back last summer. So in this case, if we step back to M&D, please talk a bit about what does it look like if a hospital on this call today says, that makes sense to me, I'm going to get into this right now. How do they work through that process?
Yeah, I think that the starting point with the boiler plant optimization is, I would say most of the hospitals that we do visit and have visited in the past, the teams managing the boiler plants are actually pretty good in a sense that they understand how these boiler plants are operating. So optimization is something that they generally starts to work with their service level contractors. So the key thing here is to start the conversation, look at this green healthcare checklist, work with your boiler service contractor, and see which of these could be easily done as an optimization strategy. Where there's a capital planning that's needed, that could be part of your ECDM plan, that could be part of your capital improvements that you sort of going to work with. But the starting point is working on the checklist, making sure that all the items have been discussed with your boiler service level contractor, which of them could be easily implemented because you already have the infrastructure, and which of them will become part of the capital budgeting plan. One of the measures that I do see has the biggest impact on that is staging of the boilers. A lot of the times the older boilers we've seen, they don't talk to each other. You have 3 steam boilers, they're all working on their own without even talking to each other, resulting in a lot of cycling in these boilers, especially during the summertime when there's no load comparable to the size of the boilers, and then 2 or 3 boilers are enabled. Just because they're not controlled through a common controller, they end up not talking to each other and end up cycling. You could see all of that performance data by just looking at your trend logs for the last summer or even the shoulder period season to see how these boilers are doing. Do they actually need 3 boilers when there's just a need for 1 boiler? That will help support the conversation that you're going to have with a boiler service contractor to see what could you do to make sure that there's not additional boilers coming on when it's not needed as a part of the building. So that's one of the optimization strategy that will be an easy win for you to implement and will help you result in a substantial savings at the boiler plant level.
Well, there are so many other things, aren't there? We see steam pressure that's higher than it needs to be. It can be reset down. We see boiler economizers with the bypasses stuck open and draft dampers, which are bypassing. There's just so many things within the plant that the experienced eye, the checklist captures all of those now. It's been updated. So with your boiler service contractor, just walking around the boiler room, you're going to come up with 5 or 6 or 8 things, and they make a big difference. They're very measurable on the screen. So these are, again, this is our low-hanging fruit number 2. And Michael, can we switch to here we go. We've got the poll on this one now. So you see our questions, how much life is left in your boiler plant? And then secondarily, what are the things that would make you anxious about stepping up and really making significant changes to improve the efficiency of the plant? And thanks everybody on the call for your active participation in the polls. This is going to be the most useful guidance that we get in the next 12-24 months of greening healthcare from anywhere. Thank you for making the time to do this. This is helpful because the age of the plant obviously dictates what kind of opportunities we're looking at going forward. And again, thanks for sharing the areas of concern, things that get in the way. These are the things that we will be working on and looking to address and help everybody move forward.
So there's a question that just came up that if if the hospital has a good operations team, many of these should already be implemented. Are we going to speak to any barriers preventing discovery and implementation of these initiatives?
That's right. A capable operations team with or operators within the boiler plant, many of these things should have been tackled, and the checklist is there. And love to have whoever asked that question, love to have you pull the checklist down, or Michael can forward it to you. Pull it down from the Greening Healthcare website and check off, are all these things being done? And if so, we can relate that directly to the gas use of your hospital, and it will look good. When everything's done the way it should be, the numbers will support that. So closing that loop would be helpful. But we've yet to go into a boiler room in any hospital and find everything is the way it should be. So there's generally something that's been missed. So let's talk about enthalpy wheels, thermal wheels, heat recovery wheels. So typically on 100% outside air systems, you see the typical graphic on the right-hand side. The key area of interest for us is always the preheat coil. We've had 2 years now of work with a number of hospitals on optimizing that preheat coil set point, because the more heat that the preheat coil puts in, the less heat that the heat wheel is able to recover. We've come across a number of concerns and issues that hospitals are troubled by, that prevent them from making full use of these heat recovery wheels. The effects when they're optimized, we've documented and shown, and you'll find, again, material on the Greening Healthcare website, again, is in the tens, even hundreds of thousands of dollars a year of utility cost savings, typically gas or fuel oil cost savings within there. So the issues with thermal wheels, the preheats are typically set too high, and we'll find the thermal wheel is underperforming for a number of different reasons. These things are correctable. And Amandeep, speak to what you found, and again, how does this move forward?
Thanks, Ian. So yeah, and in most of the sites, it's one or the other issues happen with the thermal wheel, and then the whole wheel becomes basically a nuisance in operation. So generally, the simplest things to do in those cases is to turn off that wheel. And what it does, as Ian pointed out, it just takes that whole amount of gas now you have to use to heat up that air, where wheel should have been used and was designed to do that. So optimizing the thermal wheels is one of the simplest measures that you could do. Work with your equipment manufacturer, work with your controls contractor to ensure that your wheels are working as intended. Now, the concerns we see is that is around freezing of the wheels, freezing of the coils, but those all issues are sort of have been addressed in previous conversations, previous events, and we have worked with many of these hospitals. There's many hospitals, when you look at their gas performance data, you can easily tell the hospitals that are using or sort of optimize the thermal wheels operation, their gas consumption is way lower than the hospital which haven't. So if you have a thermal wheel in your facility, which majority of the hospitals do have, highly recommended to consider this measure, implementing and ensuring that the thermal wheels are optimized, and working with your AHU manufacturers to know what your limitation on the thermal wheels are, and then communicating those limitations with your control contractors to reset the wheels so that your preheat coil temperatures are set low enough that the wheel has the ability to extract that heat and put that back into the outside air system. So simple modification on the controls, monitoring it through your building automation systems will lead you to deliver a measure that's going to save you a significant amount of gas in your building.
And when the thermal wheels are working well, it's the heating thermal, it's the extra assumed gas consumption for heating and humidification in the wintertime where it shows up, which is the impact on outside air and humidification of outside air as well. That's where we can tell if you've got a lot of thermal wheels. So let's, if we could, move on to the poll. This is 3 of 5 subject area polls, and here are the questions. Once again, if you don't have any of these, then it's 0%. But if you have them within your hospital, just make a rough estimate of about how much of the hospital they serve. Is it all of it, part of it? Humber River Hospital, for example, is pretty much 100%. So figure out how much of your hospital is actually served by, or is served by air handling units that have enthalpy wheels or other forms of heat recovery wheels. And then we know the scale of the opportunity.
Yeah, while the poll is going, I think one of the biggest concern, as I was pointing, is the freezing of the coils that's been referenced in a lot of these sites. And in some sites, we've seen that the sites actually drain the cooling coils and they have the freeze stats installed in front of the cooling coil. They're still concerned with freezing of the coil. So some of the concerns are genuine, but some of them is the concerns wouldn't qualify in a case when you're actually draining the cooling coil. There's no water to freeze in those coils. So these all could be easily addressed through conversations with even your own teams probably would have those answers for those questions. But these are all fair concerns, but they're all addressed through the conversations. And they're currently enthalpy wheel operating at an entering air temperature of -16 across Alberta, Ontario with no issues at all.
With no preheat. One of the concerns I've heard on a number of times is the preheat coil itself. If it's a steam coil, that's a cause of anxiety. Is that right? Because it's going to be closed.
It is, yeah. If you have a steam preheat coil, then it's a different story in terms of leaving that unintended, because that's a potential on freezing. So for those cases, there are mitigation in those as well. Like you could work with your steam coil manufacturer to understand what is the minimum pressure you have to maintain on that coil. That gives you still savings, but it's not as high savings as no preheat coil running. But there is still potential to work with the steam coils where your preheat is a steam coil. But it is a bigger concern for freezing on those coils versus any other preheat or cooling coil in the system.
So it's freezing in 3 areas. There's the preheat coil, potentially, if it's not glycol. Then there's downstream coils like the cooling coil if it's not been drained. And then perhaps the bigger one is the exhaust air whole side of it, the other side of the wheel, the exhaust air side of the wheel, and the ductwork around that. We've seen pretty heavy frosting on ductwork when those wheels are working really well. Is that right?
Yeah, around the ductwork, if you have a exhaust ductwork leaving the building, which is uninsulated, then yes, there would be concern. In most of the systems, what we find is there's not generally an exposed exhaust ductwork, because exhaust is right connected to the exhaust air plenum. So hence there's no exhaust exposed ductwork. But yeah, if you do have exhaust exposed ductwork, you got to make sure that the dew point in that space is not lower than the leaving air temperature of that ductwork, because then you will see condensation happening on the ductwork itself. So, but again, that's very unique situation in some of the hospitals where there's no exhaust insulation ductwork. But in other cases, the exhaust ductwork is either insulated or it's right next to the plenum, so there's no exposed ductwork anyways.
So lighting retrofits. A couple of years ago, we were talking with a couple of our friends within the lighting industry in a number of hospitals, and the history at that point was the majority of lighting retrofit projects didn't deliver the level of savings that had been anticipated, and in many cases there were areas where the light levels were significantly higher to the point that occupants were uncomfortable. So this report that you see on the screen here, it's up on the Greening Healthcare website, worked with industry and 2 participating hospitals to figure out a better way using data logging, using power density levels, looking at emergency lighting, and is that the right amount? And under different operating scenarios, hours per year of use, what was the right approach? Would it be a whole fixture replacement or relamping, reballasting? So that work was done a while ago, and again, the guide is up there. It's being used, but if we step into, if hospitals look at this and say, yeah, time to look at LED lighting retrofits. We know there's mercury regulations coming into effect in Canada that are going to make fluorescent lamps difficult to work with over the coming years. So how should a hospital step into these projects? The planning, are hospitals doing everything at the same time? Are they doing it in phases? Like, how is that working, Amity?
Yeah, I think a lot of the hospitals, they're following different paths. Some of them, we know, for example, procured fixtures, and then they're using their in-house labor to install them as they find time. Some of them are considering these as phase projects where they're using different phase of the building and then working with a third-party consultant and a contractor to do a big retrofit in those. In certain hospitals, they have either using sort of a lamp replacement as an opportunity to replace these existing fixtures to LED. So different sort of hospitals have different paths on this. However, what we recommend is to sort of, whichever path you follow, is to sort of at least reference the Green Healthcare Lighting Guide conversion, just to make sure that working with your contractor or consultant, you covered all those factors in ensuring that you get the right product in the end, and then you don't have to redo this again. Because one of the things that we noticed in the past when some of the hospitals did the work is that they didn't plan for a too bright lighting, LED lighting, and which basically resulted in a lot of complaints for the end user. So they had to make some changes to the appearance of the fixtures by doing some manual upgrades on those ones. So that's not where you want to end up with your lighting project, but this is more what you're currently doing, ensuring that the right solution is implemented, and it's also considering the life cycle costing as a means to make sure it's not only totally dependent on the capital cost, because eventually your controls aspect is going to be also considered as you upgrade these lighting fixtures to LED, because the lighting comfort becomes a major issue with these upgrades.
I think we found that data logging was very insightful initially in saying that, wow, as you looked at individual panels and what was connected to those panels and what the power draw actually was, that there were in some cases big discrepancies, like fixtures weren't alive, they'd been disconnected, they'd gone, they'd changed. So the data logging was one of the interesting ways of both making sure the initial audit was correct, but also then verifying the savings after the fact. Does that sound right?
Yeah. No, that's absolutely right. Michael, do you want to turn on the poll? And I have another comment, so I just want to save the time in that as well. One of the, yeah, no, that's absolutely right. Data logging is a key piece and an outcome of that research work that we found is it not only does it helps to establish the sort of the base case for your fixture improvement, but it also lets you also accurately calculate the savings that were most likely projected in your proposal, but then it also helps you document those savings as well. One of the things that with the upgrade controls that you can also consider is to look into your emergency lighting in the systems. As you upgrade your systems, the emergency lighting design have changed over the years. So you might see too many fixtures on emergency lighting, but when you upgrade your fixtures to LED, now you have the option to pre-program those systems to normal lighting if it's not needed. So considering that which areas and how many fixtures you need for emergency lighting, and using the functionality of your new controls and programming those fixtures will definitely help save on additional savings on the lighting upgrades.
And again, the data logging was pretty clear. Where there was too much emergency lighting, you could see it at 2 o'clock in the morning, right? It's and you can look at that at watts per square foot, and that was pretty easy to pull out. So much better insights. We're working through question 4, just one left, and then we got the big question towards the end of where do you see the biggest opportunities of the areas we've touched on today, right? So pump systems. Nothing like as big as fan systems. The pumps are smaller, but we're especially in the last few years finding really big opportunities attached to hydronic systems and pumping energy use and increasing, as those little bullet points say up there, variable frequency drives increasingly make sense, replacing control valves, many control valves being replaced with two-way valves, which were previously three-way valves that offer pumping savings as well as better control. The number of, even with variable frequency drive pumps, the number of triple duty valves that are throttled way back and just opening them up and letting the fans back off. We're seeing quite remarkable electricity savings around pumping, especially on heating loops, even though those pumps are often smaller than cooling loops. They run year round. In fact, very often they run 24/7. And I think you touched here on the pump scheduling. You know, why are glycol pumps running when they're only really needed in the coldest weather? So, take us through that. How do you begin? How do you move forward with pump optimization?
Thanks, Ian. Yeah, so this is one of the measures that does help in a lot of ways as well. So in the past, when the pumps were designed and they were installed, the triple duty valves were used to balance the overall flow in the system. However, when the VFDs get added into these systems, the triple duty valves in most of the cases were left as it is in that same position, and the VFD was installed on top of that. But the triple duty valve then in that system is not doing anything other than just adding extra static in your system or pressure, right? So opening up these valves, balancing the flow just to through the VFD will create that 10, 20, 25% savings depending upon what's the valve position on those. So the starting point for that particular measure is to have your plumber probably create a work order for them to go check out the triple duty valve position, then note down the VFD speed for all the pumps in your facility and come back to your report. You will see clearly on that list is that the triple duty valve position 60% open, and then the VFD speed at 100%. You can then get a ultrasonic flow meter, note down the flow, and then rebalance your system by opening up the triple duty valve and backing up the VFD. So that's your savings for that system. And this all could be done in-house through your existing trades folks, and they love to do this kind of work because there's associations around energy savings with it. Similarly, on other measures around making sure you have the right differential pressure set point in these pumps. So measuring that differential pressure set point is a key in the field rather than relying on arbitrary value, which again will create that extra static pressure, which is not being used with any of the systems of the flow. One last thing I want to mention here is, Michael, you can turn on the poll on this one as well. There's been cases where we noticed or we saw that the facilities are struggling with a chilled water flow or reaching out the flow. But when we looked at the secondary pumps or even the primary pumps, the same thing is happening on those systems. The VFDs are full out, but the throttling valves are closed to 60, 50%. So there's still enough capacity available in the pumps itself by increasing the flow. And this might be, and facilities are actually considering to upgrade their chillers because they can't meet the flow. But this will be the starting point. I think if I were to recommend suggest that look at your pumping flow to make sure that you don't have excessive pressure loss through these triple duty valves or incorrect differential pressure set points in your systems, and that's causing your restriction in the flow versus actually the chiller. Chiller may not be an issue. It may be a pumping that's causing that issue for certain systems not achieving the right amount of flow.
And indeed, we're seeing three-way valves, especially old pneumatic three-way valves, changed out fairly often. If they're on heating and cooling coils, if those are three-way valves, are you seeing those converting now to two-way valves, flow regulating valves? Is that happening, or often they just putting better, newer three-way valves back in again? What's happening on that?
I think generally it should be two-way valves. but again, like that's how the sites are sort of, it's dependent on how sites are doing that work. But I've seen a lot of the conversion now is happening to two-way wells because a lot of the facility owners and operators understand, hospitals understand the implications of constant flow versus a variable flow. So they're picking up on the idea, and then a lot of the ideas actually come from their tradespeople, like the plumbers. They're asking that question: why are we changing this to a three-way valve again when we have the opportunity to put a two-way valve here since it's being replaced, right? And similarly, there's other smart valves out there, like energy valves out there, that if you have a potential issue on the delta T's, considering those as an option on some of the systems could be a good starting point to understand if that helps your delta T on the system. If that helps regulate the flow in your system, so you can get a flow down basically to the end of the loop versus the middle of the loop, right? Or even the start of the loop. So having those capital planning on VFDs, on pumps and valves, to consider that how your system's being set up for the future is going to be the key, because if you put a three-way valve now, it's going to be hard to make a business case for a two-way valve down the road.
So you see pump energy savings through this, but you also see much better delta T's, which improves plant efficiency. And when we start moving to heat recovery chillers, which most hospitals are going to be seeing, that delta T is going to make a big difference.
Yeah, absolutely, and that's what's needed to get that load on that heat recovery chiller, so you can maximize the heat recovery through that system.
Okay, I'm watching the polls and loving the feedback, and if you'd bear with us just one last time, there's one final big question we have on the final poll, which is where do the hospitals on this call, there's a lot of you, where do you see the opportunities? And can you just tell us, between the 5 measures we've looked at here, what do you think of the ones you'll move forward with? And again, we make this commitment to you, especially around the summer workshop. We're going to focus on the things that you want to move forward with. So if you could just, and again, promise that's the last time we ask today, if you could just fill in these ones from the options you have here, which ones are just not practical within your facility, which ones are certain that you've looked at it, you've heard about it, you already planned it, or you're going to plan it now. Tell us which ones you plan to proceed with. And again, we will be sharing this information with your utility companies. We're working more and more with governments around how can they help you move forward. So if you can tell us from everything you've heard today, where do you think your low-hanging fruit are, and help us then design the ongoing support Greening Healthcare will be providing along with our partners going forward. And once again, I see the numbers building up, and this session was always a leap of faith as to could we really impose upon folks as much as we have today. And again, I just really appreciate the responsiveness and give you our assurance we're going to be using this information and using it in your interests. And Amandeep, while people are working on this, thank you for being so concise. We're almost on time. I didn't think there's any way that we would get through 5 subjects in 1 hour, but this has worked out very well. Conscious of time, and I think the poll's still open, so please keep working on it if you haven't finished your most thoughtful answers so far. But let's just close a little bit with where Greening Healthcare is going over the balance of this year. One, it's going to, as I said a couple of times, be significantly affected by what we've learned from you today. Going back to the beginning, we're very conscious of the urgency around the climate crisis and the fact that hospitals have such a big part to play. And you're also at the front line, as you know, with as respiratory diseases build up. Dr. Cohn, 2 years ago in our keynote for the CEO of Sick Kids Hospital, made it very clear that I think it was 78% of childhood illnesses could be linked directly or indirectly back to climate change. This is a big issue for the healthcare sector. We have the opportunity, the responsibility to do things. Greening Healthcare is there with you. That's the only reason that we exist. And the plug will always be there. Join us. We've got a lot of our members, and bless you for being with us. There's a lot of non-members here, and we'd love to hear from you. Excuse me. You'll find, again, make friends with greeninghc.com, the website. All of the events are are right there. The webinars, the February 7th one, the recording from that is there, the Planning for Success. That was our big planning session for the year. This is today's session, which is picking the low-hanging fruit. July 31st, another webinar where we'll be looking at the energy savings leaderboard and closing the loop with everything that we've talked about today. We have our annual new hospital performance webinar coming up in September. We're looking at how are the brand new hospitals, the hospitals built in the last 15 or 20 years, how are they comparing? And we have some interesting work we're doing with the federal government to report back on that at that time. In person, we haven't finalized the June event yet. It'll be the June the 3rd or the 10th will be our summer workshop. And again, roll up the sleeves and really getting into actions that hospitals can take. And our strategic event is November the 4th this year, again at the Delta Hotel in Toronto. So please plan to join us for that full day event where we set the stage for 2025, but also look really hard at the trends, the policy directions, the regulations, what is happening around this whole climate change front and carbon reductions. And once again, if you're an industry participant, welcome here. Think about what you've heard today and how you can help hospitals succeed. And we love to have new industry and as well as hospital members, sponsors working together to move the needle on this whole event. I'm Ian Jarvis. As you know, Heather Bell is on this call today. She's our Director of Program Partnership Development. If you're interested in exploring becoming part of Greening Healthcare, Heather is the person for your contact. Michael is our program manager for over a decade now. He's the day-to-day interface relationship, and Amadeep heads our technical team that's going into hospitals, making these things happen, making them work. So thanks to all of this team. Thanks to everybody for being such helpful partners in moving this agenda forward today. We will be back, we'll be in touch, and we look forward to continued success, continued savings. Thank you all very much. Bye.